All right, welcome back. And today's lesson is on the distance of segments. You have the worksheet, or you got it in class. If not, it was attached on School Loop. You'll notice that I have three different colored pens and a protractor or a straight edge. We're actually going to use the straight edge today. So let's get started. It says plot the endpoints and draw a line segment from below. Then determine the distance of each line segment, first using the distance formula, then using the Pythagorean theorem. So let's first get started with writing down what the distance formula is. I'm going to write it over here on the left side provided. So the distance formula is D is equal to, and then a really long square root. And then we have two sets of parentheses. We're going to square them. We're going to add, and then another set of parentheses that we're going to square. And the distance formula is x sub 2 minus x sub 1, and then y sub 2 minus y sub 1. And that's your distance formula. And then the Pythagorean theorem over here would be a squared plus b squared equals c squared. And I'll put a little df, distance formula, pt, Pythagorean theorem. Okay? And now we're going to come down here and we see our points. So we have a point A of negative 4, 4, and B positive 3, 2. So negative 4, 1, 2, 3, 4, 1, 2, 3, 4. Negative 4, 4, A. And then B of 1, 2, 3, 1, 2, B. And I'm going to use my straight edge right now. I'm going to draw that line. Now the distance formula. We don't need the line and we don't need the image. We just need the sets of coordinates. So we're going to put the distance formula that D is equal to the square root, parentheses squared, plus parentheses squared. And then we're going to do, let's go, this is our second 2 and point 1. And then we're going to go x2 minus x1, so negative 4 minus 3. And then we'll do y2, positive 4, minus y1, which is 2. And then we're going to simplify. So d is equal to the square root of negative 4 minus 3 is negative 7 squared, plus 4 minus 2 is 2 quantity squared. And then I'm going to slide it up here a little bit so you can see. And then we're going to do d is equal to the square root. Negative 7 squared is negative 7 times negative 7, which will be 49. Plus 2 squared is 4. And then that is going to simplify to d is equal to the square root of 53. And if you take your calculator and you do the square root of 53, do it on my phone here. There's a clear button. So on my phone, we have this. You do square root 53. That equals 7.280. So I'm going to do 7.28. And that would be your distance. Square root of 53 is between 7 and 8. So that gives you an idea. For the Pythagorean theorem, we are going to need a right triangle. So we're going to use our slope triangle that we have so many times in the past and come up to the image, and I'm going to make a triangle. And I'm going to go there and there. We have a right triangle right there. I notice that I have 2 units here, and I have 1, 2, 3, 4, 5, 6, 7 units there. So those are my legs. So 2 squared plus 7 squared is equal to c squared. 2 squared is 4. 7 squared is 49 is equal to c squared. 49 plus 4 would be 53 is equal to c squared. As we did in class the other day, we are going to square root both sides. And the square root of something squared just leaves it to be itself. And then the square root of 53 we learned already was 7.28. And that would be the distance using the Pythagorean theorem. Since it is the same endpoints, you should get the same answer for your distance. Personally, I think doing the Pythagorean theorem is a heck of a lot easier than doing the distance formula. You have to figure out one number and another number by making your right triangle, and then you just plug it in, square them, add them together, and then find the square root. Let's move on to our second example, line CD, and let's do the distance formula first. D is equal to the square root of squared plus squared. And then we have our second point and our first point. Doesn't really matter which one you pick. And we'll go x's first. So 2 minus 8 there. And then we'll do -5 minus 0 there. Simplify our radical. 2 minus 8 would be -6 squared. Plus -5 minus 0 would be -5 squared. -6 squared would be 36. -5 squared would be 25. So the distance is equal to the square root of 61. Square root of 61 is going to equal, my calculator out again, bring it over here, clear it out. The square root, 61 square root, 7.810, so 7.81. Excuse me, sorry. And that would be our answer for the distance of that line. If we're going to use the Pythagorean theorem, we're going to plot the points, which is what I would do. +2, 1, 2, 3, 4, 5. -5, this is point C. Point D is 8, 0. Take my straight edge, draw my line. And then we're going to figure out our triangle. So I scroll over, make my horizontal line for the right triangle, which would be 1, 2, 3, 4, 5, 6 units here. Our vertical line, 5 units there. And then we plug them into the Pythagorean theorem. 6 squared plus 5 squared equals c squared. 6 squared is 36. 5 squared is 25. 36 plus 25 would be 61. Find the square root. Find the square root. They cancel, and you get c is equal to the square root of 61 is, we found out, is 7.81. You do not have to use both the distance formula and the Pythagorean theorem. You're going to select which one you want to use, as it doesn't really matter. You'll get the same answer using both. My personal preference is the Pythagorean theorem because I think it's easier. What I would like you to do for the rest of homework is to complete these last 2 questions. See what you do, see how you do. If you have any questions, again, I recommend that you watch the video more than once, and then you come to class with any questions that you have after watching it at least 3 times. Have a good night, take care, and I'll see you tomorrow.